Hello everyone, welcome to Practically. We bring learning alive. In today's one short session, we are going to discuss electromagnetic waves, grade 12 physics. See, in class 12, term 2 syllabus, if you check once, 7 chapters we are having, and in that electromagnetic waves is one important, interesting and easier one. Let's begin the session. Electromagnetic waves. Yeah. Introduction. In Oersted experiment, we have learned when electric current flows through the conductor, surrounded by the conductor, magnetic field is developed. That's the beginning experimental analysis of Oersted experiment. So what we have learned, when electric current flows, magnetic field is developed. Okay. And later, Faraday's laws we have learned. What is that Faraday's law? The rate of time varying magnetic field can produce electric field. This one, Oersted experiment. From Oersted experiment, we have learned when electric current flows through the conductor, magnetic field is developed. And Faraday's laws revealed that the time varying magnetic field can produce electric current. That means it can produce electric field. Now coming to the point, the converse of this statement is true. Is it possible? What is that? Time varying electric field produce magnetic field. Can time varying electric field produce magnetic field? Converse of the statement, that means Faraday's laws we know, time varying magnetic field can produce electric field. What about its converse? Yeah, actually this is explained by another scientist called Maxwell. Actually, in Maxwell point of view, he believed strongly in the symmetry in the nature. Like you know that symmetrical, how that will be. See, Faraday's laws he observed magnetic field, time varying magnetic field is producing electric field. Then what about its converse? Is it possible to produce magnetic field with the help of time varying electric field? So he just believed strongly in that symmetry in the point of nature especially. So then he started doing experimentals, everything, and he predicted theoretical analysis in 1865 itself. And later on, his whatever the analysis, whatever the theories were predicted by him are proved by followed another scientist, another physicist, Hershey you can say, and then later J.C. Bose from India, Jagdish Chandra Bose from India, as well Marconi from Italy. So it's led to beautiful destinations. Development of wireless communications, XYZ, etc. Okay, so then the converse of this statement, can time varying electric field produce magnetic field? Yes, it can produce. That's possible. So then further it leads to the development of modification of Ampere Circuit Law. So here Ampere Circuit Law we have learned. What is that? To calculate the magnetic field for a closed path, closed loop, we are using that Ampere Circuit Law. Like what? With the help of Oersted experiment, it's very clear. When electric current flows through the conductor, magnetic field is developed. So there, if you take the closed loop to calculate the magnetic field, which is developed due to the flow of current I in the conductor, then we will apply Ampere Circuit Law, which states that the line integral of magnetic field of any closed path is equals to mu naught times of current threading in the loop. Okay, that's what Ampere Circuit Law. What is that? Line integral of magnetic field for a closed path is equals to mu naught times of current threading in it. Say mu naught I is the current threading in that loop. Okay. Now Maxwell found that Ampere Circuit Law is inconsistent. It's not consistent everywhere. there is some inconsistent, there is a missing term in that law. What is that missing term? How he has explained. So in that explanation, we are having a new term, that's what called displacement current. The current which is there in this expression that I represents, it's a conducting current which is conducted by the connecting charges. Apart from that, okay, and another term is presented in that, then only that Ampere circuit law will become consistent when you are applying to the closed path. So what is that missing term? Let's find out. So for that, he has taken the charging of a capacitor. Suppose let I is the current which is flowing through the conductor here that can charge this condenser or capacitor. It's a time varying current. I mean the current is a function of time here. Then the charge is developed over here and the condenser is charged. So say here this is a negative charged one, as we know that plus q, let it, this is minus q. Alright, now according to Oersted experiment, it's very clear, magnetic field is developed when there is a flow of electric current, right? So take a point here, somewhere else here, where we have to find out the magnetic field, say the point P over here. Okay, so I am taking a closed loop to apply the Ampere circuit law. Let the radius of this closed loop, let it be small r. Now at point P, we have to calculate magnetic field. Apply Ampere circuit law. What is that? The line integral of magnetic field for a closed path is equals to mu naught times of current threading in the loop. So I of t, this here we have taken I of t is the conducting current. Let it be whatever. I of t is the current which is a function of t, which is a function of time, is flowing through this wire. Now here b bar dot dl bar, this is a vector form, right? We can write it as like this, mu naught times of, let's say this is conducting current, I of time. Then b bar dot dl bar, here both this b bar dot dl bar you can write b dl cos theta. Okay, so then b integral dl is equals to mu naught ic. Integral dl is nothing but the circumference of this circular ring. Circumference of the circular ring having radius r will become 2 pi r. Then b multiplied by 2 pi r is equals to mu naught into ic we will get. Okay, then here it's very clear, b is equals to mu naught into ic by 2 pi r. Okay, that means magnetic field is presented at point P here when you are applying that Ampere circuit law for this closed ring. Okay, now I am taking another surface which is having same circumference. The surface shape may be different, like say the kind of the surface is a pot or a balloon or a tiffin box without lid. Okay, so you take some different surface, the same one I am taking now, same condenser here. Okay, and the same amount of current is flowing through the condenser. Same point we have to take. I am going to take the same circumference, but this time this is of another shape. You may take this is like a balloon kind of shape, or else a tiffin box kind of shape, or else a pot kind of shape, whatever. And then the same, the radius of this this circular path, whatever is there, whatever that you are able to see here, let it be r, the same one. And the point P here, again I am going to calculate the magnetic field. But this time when you are applying the same Ampere circuit law, here when you have applied in this case, we got the magnetic field which is constant everywhere in this loop. Alright, now at the same point P, For the same circular ring having radius r, I am going to apply Ampere Circuit Law. The left side parameter, which means that closed integral of v bar dot dl bar, there is no change in the left side parameters, left side expression. But if you look at this, the right side, which is mu naught times of I, here this I flow through this surface is 0. There is no flow of electric current in this surface. I is 0. And see, you have to make sure that when you are keeping this arrangement, that should not touch this wire, which means the pot or the surface of this body should not touch the conducting wire, and it should be placed in between the plates of the capacitor or condenser. Then the current flowing through the surface is 0. Where will we get the total value of this is 0. Mu naught times of 0 is 0. So here arises the point. This Ampere Circuit Law is not consistent in both the cases. In the first case, when I have taken here this analysis, magnetic field is existed, and here magnetic field is not existed, but still capacitor is charging. Capacitor is charging, which means some other additional current is existed here. Suppose if this due to the placing of this pot kind of surface or else balloon kind of surface here, if capacitor is not charging, that is different case, but here it is charging, and whereas I is 0, the I that is flowing over here is 0, but still capacitor is charging, and magnetic field here we are getting 0 because of I. Because of I at this point B, it should not be happen. It should not happen. Capacitor is charging, electric field is produced, and electric field, suppose if it is time varying or oscillating, it can regenerate magnetic field again. Yes, oscillating electric field can generate oscillating magnetic field, and oscillating magnetic field can regenerate electric field. So each one they are regenerating themselves. Okay, so the point is very clear. For the same circumference, for the same ring, for the same circular loop, at this point magnetic field is existed, and when I have changed the surface nature, like some other different surface when I have taken with the having same radius, at the same point I am not getting the same magnetic field, but still electric charge is there. The capacitors are being charged here, electric field is existed there. So it means their magnetic field will be developed. The thing is here to show magnetic field is consistent, that's constant in both the cases. But if I am applying Ampere Circuit Law, it's not being obeyed. So to show it as consistent, then Maxwell explained here, yes, that explanation up to here is fine. To make the magnetic field is consistent, current is required. Yes, current is there, but this current if I am taking here, it is 0. That means this is also true statement, current is 0. Then something else is making the magnetic field consistent, not this current is whatever the IC I have taken, conducting current is making, or else is with the help of that we can find magnetic field outside here for this case. But in this case also magnetic field is consistent, but when I am taking this conducting current, I am not getting magnetic field, that's why I am getting a 0. To make it consistent, some other parameter is helping. What is that parameter? That is what displacement current. That is what displacement current. Outside of the plates, conducting current is 0 here, that means that IC is 0, but still there is a development of magnetic field between these, electric field between these two plates, that's directed like this. Got it? So that electric field which is produced in between these plates is varying with time. So the time rate of electric field, that varying electric field, timely varying electric field is going to produce current over there. That current we are calling it as displacement current, which is responsible for making magnetic field consistent. Then you can say by including that displacement current, you can make Ampere circuit law consistent. That is what the explanation. So it's clear here, in the process of charging here, electric field is directed here, and from Gauss law, flux developed here can be written as, it is the product of electric field and aerial vector, let it be E bar dot A bar, Ea cos theta, as theta angle between the two is 0, two vectors is 0, cos 0, 1. So Ea, and electric field in terms of charge, how can we write? 1 by epsilon naught times of charge by area and multiplied by area, area get cancelled. So flux phi E is equals to Q by epsilon naught. Alright, now differentiate with respect to time, because time varying electric field I said, which means electric flux also will vary timely. So time varying electric flux d phi E by dt is equals to dq by dt 1 by epsilon naught times. So then epsilon naught, if you bring to this side, epsilon naught times of d phi E by dt, that is equals to dq by dt. Here dq by dt is nothing but generally the time rate of change of charge, right? So time rate of change of charge is called what? Current. So here dq by dt is equals to current. What current? Here we are talking about displacement current, which is represented by id. So id is equals to epsilon naught times of d phi by dt. Now this is responsible for making electric field constant even when you have taken this kind of surface. So here how can we say magnetic field at this point is constant? We can say that is constant not because of conduction current, it's because of displacement current. So one important point here, conduction current here exists outside of these capacitor plates, but in between these plates, inside these plates, which means inside in the sense in the inside interior region of the two plates, displacement current will play a crucial role for making magnetic field constant. How that magnetic field has produced here? That magnetic field is produced by the timely varying electric field. That's clear. A timely varying electric field can produce magnetic field, so which is symmetrical to the statement that we have discussed in the earlier case. So there ends the conclusion of that statement, and his analysis further carried to the development of to understand and analysis of electromagnetic waves, and later the discussion is led by Hertz as well as another renowned physicist, as I said, J.C. Bose and Marconi, etc. Okay, fine. So it's very clear then, magnetic field here it is maintained constant by the help of both conducting current as well as displacement current. Now that's the Ampere circuit law. So far we have studied, that means before this lesson, and now here the modified Ampere circuit law can be written as with the in terms of this displacement current, that is the closed integral of line integral of magnetic field of a closed path is equals to mu naught times of total current that you should represent in terms of conducting current and displacement current. Therefore closed integral line integral of magnetic field is equals to mu naught into IC plus, so this you can write it as epsilon naught times of d phi E by dt. This is the Amperes Maxwell law, or we can say modified Ampere's law. Alright. So then later Maxwell developed by combining both electric and magnetic fields, and with the help of Lorentz force equation he developed some equations which we are calling them as Maxwell's equations. So the standard 4 Maxwell's equation, here they are like this, and these Maxwell's equations has helped a lot to explain the electromagnetism very clearly. Okay, so what are they? First one, E bar dot dA bar, which means Gauss law of electricity. We can write it as, what is that Gauss law of electricity? Charge enclosed in the flux, the total amount of electric flux that's enclosed in the surface is equals to 1 by epsilon naught times of charge existed or accumulated there. Okay, and this is called Gauss law for electricity. And then Gauss law of magnetism, the surface integral of magnetic field of a closed path is equals to 0. Okay, this is called Gauss law of magnetism. And then the line integral of electric field for a closed path is equals to, what is that? Time rate of change of magnetic flux. This is nothing but what? Faraday's laws of electromagnetic induction. We have learnt in electromagnetic induction. A timely varying magnetic field can produce electric current. So this can explain, this is nothing but Faraday's laws of electromagnetic induction. And then another one is the line integral of magnetic field of a closed path is equals to mu naught times of sum of the current that is flowing in the circuit, that is sum of the current conduction current as well as displacement current. This is called Ampere Maxwell Law. So these are the 4 equations which we are calling as Maxwell's equations, and these are developed by the help of both electric and magnetic fields, keeping in mind. Okay, and these laws explains the concepts of electromagnetism very clearly and very in understandable manner. Okay, so this is Gauss law of electricity, this is Gauss law of magnetism, Faraday's law, and then Ampere Maxwell law. This is about displacement current. So displacement current is nothing but generally current. How will we define? The time rate of change of electric charge, right? So in the same manner, the time rate of change of electric field or the time rate of change of electric flux, hence electric field, or electric field hence electric flux, is what we are calling it as displacement current, or another name for that is Maxwell's displacement current. Okay, fine. So let's move on to the next topic. Electromagnetic waves, source of electromagnetic waves. All right. Source of electromagnetic waves. What is the basic source of electromagnetic waves? As we discussed, who is the scientist? Maxwell. In 1865 itself, he predicted that development of magnetic waves, electromagnetic waves. All right. We know that stationary charge can produce electric field. We have learnt in electrostatics. Stationary charge can produce electric field. A moving charge can produce magnetic field. We have learnt in moving charge and matter. In fact, Oersted experiment also, through that we have learnt. But what can produce magnetic waves, electromagnetic waves? That's the point here. So what is the source of that? Source of electromagnetic waves. If you take stationary charge, that can produce only electric fields. If you are taking a moving charge, uniformly moving charge, that can produce magnetic field. But how can electromagnetic waves will be generated? By the help of an accelerated charge. an accelerated charge can radiate electromagnetic waves. So this is explained even by experimentally by Hertz. Okay, of course his experiments are stick on to laboratory. Fine. So then he explained about all this experimental analysis of generation of electromagnetic waves. We are having Hertz experiment also. So here the source of electromagnetic wave is accelerated charges, and accelerated charge or accelerated charges can radiate out electromagnetic waves. Suppose if you take a charged particle which is oscillating in a space or in a region, there the oscillating charged particle can produce electromagnetic field, timely varying electric field. That timely varying electric field, and it's very clear that it can produce timely varying magnetic field. Just now we have learned with the help of Clerk-Maxwell's statement, and we have learned it through displacement current also. So oscillating charged particle can produce timely varying electric field, which further can produce timely varying magnetic field. That timely varying magnetic field can produce again timely varying electric field. So then these each fields are going to regenerate. So because of that, electromagnetic waves will be radiated out. Okay, so that means the energy that is existed is a combination of both E and B fields. That means both electric fields and magnetic fields. So together they will be radiated out in the form of electromagnetic waves, and there ends the conclusion. Actually, to prove this it's not that much easy like a delivery of a statement. As I have said the statement, it's not that much easy to prove it. Okay, fine. So the source of electromagnetic wave is an accelerated charge. Accelerated charges can radiate electromagnetic waves. All right. So and then 1865 he gave a theoretical prediction for it, and then 1887 around Hertz said the experiment analysis for this production of electromagnetic waves, and of course his experiments are confined to the laboratory. And then in the year after 7 years almost, in 1894 to 95, Jagdish Chandra Bose, he contributed his analysis. These discussions are led to development of so many innovations in that J.C. Bose. Then with the help of his experiments, continue whatever he has learned from that Maxwell's theories or Hertz conclusions, he has developed producing an observation of the electromagnetic waves ranging from 5 mm to 25 mm. Okay, and then later the same analysis and then is continued by another scientist called Marconi in the year 1897, and he tried to establish the wireless communication from one point to another point. Okay, how then? The spark plug we know, right? So in that circuit, the spark gap, one end is connected to the ground and another end is connected to the antenna, and the same another end after certain, from that arrangement to somewhere by keeping certain distance, there is another antenna receiver over there. So by making this arrangement, he had communicated from this point to another point without any physical connections there, any in terms of like external wires like that. So wireless connections we can say. And later around some 1898 or 1899, he is the first person to establish a wireless communication of around 50 kilometers. So in between that English Channel, I think. So in that 50 kilometers, 50. Wireless communication is developed by him, and then onwards Marconi is being called as father of wireless communication. All right. So that theoretical predictions which were developed in the earlier stages by Maxwell are led to the beautiful destination, just nothing but which we are enjoying in terms of televisions, FM radios, whatever. Okay, so this is how that it is being carried forward, and later it has undergone for so many drastic changes, and even we know that, and how we are using the telephone, Okay, how we are enjoying the telephone, mobile phone usage and all. Alright, so that nature of these electromagnetic waves, sorry, source of these electromagnetic waves is what? Accelerated charges. Alright. Yeah, source we have learned. So electromagnetic waves are generated with the help of accelerated charges. Fine. What is the nature of that charges? What is the nature of that electromagnetic waves? Yes. Here the nature of the electromagnetic waves, basically they are in transverse nature. Okay. So what is this transverse nature? You know, generally, not generally, this has happened actually in the year 19th, like in the century, 19th century, in the middle of until the middle of 19th century, there was a strong belief all the waves, including these electromagnetic waves, will propagate through the medium. How the sound waves are being propagated? Sound waves are of mechanical waves. We know that longitudinal waves, they requires a medium for their propagation. Of course, they will propagate through solids, liquids and gases. And even light, especially, there is a lot of confusion with a light wave. Light wave, later after the discovery of these electromagnetic waves, they treated that light under electromagnetic wave in the visible spectrum, that is secondary. So light also they treated, it requires a medium to propagate, and the assumed medium is what? Ether medium. In a Huygens wave theory and all we have learnt. Okay, so such that type of confusions are there. It led to some big chaos. Fine. So with this analysis, electromagnetic waves analysis, they treated electromagnetic waves are non-mechanical waves, which does not require the medium for their propagation, including light. Then conclusion ends. I mean, there ends that light point. Actually, light, until then they imagine that the requirement of a medium is necessary. The medium is required definitely for the propagation of the light wave. And later, after the discovery of electromagnetic waves are non-mechanical waves for whose medium is not required for propagating. And in that electromagnetic waves, visible rays, that's nothing but the light rays, is one of the part, and it also does not require any kind of special medium, so-called whatever the discussions are happened related to the ether medium. It's an hypothetical they are saying. Of course, even that medium is also not necessary. It is not required for its propagation, they concluded. Alright, so electromagnetic waves are transverse in nature. They are non-mechanical waves which can propagate through the medium and even in the absence of medium. Alright, so basically they will be traveling, they will be varying signs, they will be moving sinusoidally by having both electric and magnetic fields. Okay, how then both electric field and magnetic field will be perpendicular to each other, and that both fields are perpendicular to the propagation of the wave. So I will take this transverse plane, I mean that XYZ plane. Say the wave is propagating along the direction of the Z. Okay, and let electric field is directed along x-axis, magnetic field is directed along y-axis. Okay, now here say this is varying timely with respect to, I mean it's varying timely, this is a sinusoidal wave. This is related to the electric field, and with respect to this y-axis I am taking magnetic field here. Okay, so here electric field is directed like this. And magnetic field is directed like this. Both are mutually perpendicular to each other. So this electromagnetic wave is the combination of both electric and magnetic fields, and they are acting always at right angles to each other like this. and both the fields are perpendicular to the propagation of the wave. Suppose say this wave is propagating along this direction and these fields are, if I say this in this plane x, y, z, all these are three are mutually perpendicular to one another, each other, right? So wave is propagating like this and E and B fields are like this, they are existed like this. Okay, so here this electromagnetic wave, as I said, they consist of both electric fields and magnetic fields that acts at right angle to each other, and here their instantaneous values can be written as Ex, say that it has instantaneous value of electric field, that can be written as Ex is equals to E naught sine of kz minus omega t. Similarly, By, magnetic field, instantaneous value of magnetic field can be written as B naught sine of kz minus omega t. Here that Ex and By are electric field and magnetic field in terms of their instantaneous values. These are instantaneous values. E naught and B naught are amplitude values. K is the magnitude of wave vector, or you can say propagation vector. Okay, and omega is angular frequency. Okay, K can be written as 2 pi by lambda, and from here lambda is equals to 2 pi times 2 pi by K, as well as omega can be written as it's 2 pi by T. T is equals to 2 pi by T, sorry 2 pi by omega. So and the same you can write it as 2 pi nu, whereas nu is the frequency. So the speed of this electromagnetic wave can be written as the speed can be written as in terms of omega and magnitude of wave vector, it is omega by K. So that means omega is equals to, it is C multiplied by K, whereas C can be written as 1 by root times 1 by root of mu naught into E naught, I mean epsilon naught. Mu naught is permeability of free space, epsilon naught is permittivity of free space. If you substitute those values, you will get approximately 3 multiplied by 10 power 8 meter per second. So whatever the electromagnetic waves that are going to be generated in the free space, they will be traveling almost with the equal speed of the light, from gamma rays to the radio waves, whatever that segregation is, that we will discuss in electromagnetic spectrum. So this is the speed, and here this is the speed calculation in terms of angular frequency as well as K value. Suppose if there is a medium, then accordingly that value will be changes based on its nature. So that will be having different permeability, different permittivity, and then we'll get a different speed when it is traveling through medium. So what does it is concluding? What is the conclusion over there? The speed of the wave is depending on both electric fields as well as magnetic fields. All right, and in terms of in amplitude values, you can write B naught is equals to E naught by C here. All right, so this is how the speed will be depending on both electric as well as magnetic fields. Okay, so the nature of these electromagnetic waves is that is transverse in nature, and this is how they will be propagating. All right, let's move on to the next one then. Momentum and radiation pressure. Yes, very important one. We all know that wave carries energy and momentum. They will transfer energy and momentum. We have learned in waves chapter in class 11. All right. Now, what about these electromagnetic waves? Do they carry energy? First of all, do they have energy densities? Absolutely yes. Both energy densities will be presented. That means electric energy density is presented, magnetic energy density is presented. What is electrical energy density? Electrical energy density, say E is equals to half, or else okay, E is equals to half epsilon naught E naught square. And magnetic energy density, how can we write? B is equals to half B naught square by mu. Okay, let it be mu naught. In terms of free space values I have taken. Okay, so total energy density of the electromagnetic wave can be written as, this means this is total energy is equals to, it is the sum of both electrical energy density as well as magnetic field energy density. That means electromagnetic wave can transfer both electrical energy as well as magnetic energy, and we are calling it as, and so we can conclude it as energy transfer is possible. It's been there even for electromagnetic waves. Electromagnetic waves can transfer energy, and even they can transfer momentum also. The linear momentum of electromagnetic waves is P is equals to, it is the amount of energy per unit time incident. Okay, say this is small u by t, amount of energy incident per unit time per area is what? The momentum. That means say this u by t as u by a. Okay, sorry, this is just a minute, that in terms of energy intensity, that is amount of energy per unit time, okay, per speed of light. That's what you can write as momentum, and this u by t I am taking it as u, capital U by c. So this is the expression for linear momentum of electromagnetic waves, that u by t by area is intensity. What is that? Amount of energy incident per unit time divided by area will be given intensity of the radiation, intensity I. Okay, so here this momentum, if you see momentum here, it is this u is u by t. Again, don't confuse. Small u is what? Amount of energy. Capital U is amount of energy per unit time. Okay, so here momentum is inversely proportional to speed of light. Speed of light is 3 into 10 power 8 meter per second. Say it's in the free space. All right. Now, when the sunlight directly fall on the surface of our body, we'll feel that actually it's difficult to experience that. It's difficult to experience it. What? Experiencing the momentum transfer. All right. Solar energy that's being incident is not being experienced. That momentum is not being experienced by us. Because of what? Because of speed of light. We will feel that sensation of the light, but that momentum transfer we are not experiencing it, because of only one reason, is speed of light. Why? Speed of light is 3 into 10 power 8 meter per second. That's very huge value. It's in denominator. P is inversely proportional to C. C more, P less. Transfer of momentum is there, but why are we not experiencing the transfer of momentum in the case of sunlight? Is because of that speed of light is more, which is inversely proportional to the momentum. So the transfer of momentum, what we are feeling is nothing, it's nullified. We'll feel the sensation of the light, but we are not experiencing the transfer of momentum. That's the reason. Next, these electromagnetic waves can radiate the pressure. Pressure exerted by the electromagnetic waves is called radiation pressure. Pressure exerted by EM waves is called radiation pressure. We know that generally pressure can be written as in terms of force per unit area. So the same radiation pressure, let's say PR, is equals to, it can be written in terms of intensity of the light, intensity of the energy, intensity of the radiated energy is equals to energy per unit time per area, right? So that I per C, this is the expression for the radiation pressure. All right. So this is about momentum and pressure. So the conclusion here it is, how the sound waves are carrying that energy and all, just like that, similar to it, electromagnetic waves can transfer energy, they can carry momentum too, and they can exert pressure also. That's what we are calling it as radiation pressure. And expression for momentum is like this is the one, and expression for radiation pressure in terms of intensity of the radiation is this is the one. All right, so let's move on to the next one then. Electromagnetic spectrum. Yes, so we have learnt in the previous theory, electromagnetic waves are being generated by what? By the source of, with the help of accelerated charges. Accelerated charges can radiate out electromagnetic waves. So those electromagnetic waves, if they are obtained, if they are placed orderly, if they are distributed orderly according to their wavelength or frequency, that orderly distribution of the electromagnetic waves based on their wavelength or frequency is called electromagnetic spectrum. The orderly distribution of electromagnetic waves and forming distinct groups with different properties is called electromagnetic spectrum. And here you can see that electromagnetic spectrum whose classification is done based on the wavelength here. All right, and here you can find then radio waves, shorter wavelengths, microwaves are there, infrared rays are there, and this is visible rays, UV rays are there, X-rays and gamma rays. This arrangement is done based on the wavelength. Even based on the frequency also you can segregate. Actually, for segregation there is no proper line of segregating point here. Okay, and that's why in even some textbooks, if you are referring, then you can find out the frequency ranges or wavelengths almost will be same, I think you can get, but frequency values especially they will be varying, the order will be 1 plus or 1 minus, you can find that difference. That's we can say that strictly one point, that segregation is not done based on the proper line of segment. There is no proper line of segregation, proper line to segregate these waves over here. Okay, so based on the ranges of their wavelengths and frequencies, we have segregated it, and this is an alignment, this is an arrangement of distribution of electromagnetic waves based on their wavelength. Radar waves, radio waves, microwaves, infrared waves, visible light or visible rays, UV rays, X-rays, and then gamma rays. Okay, so let us see one after one by one. Yeah, radio waves here. Accelerating charges can produce radio waves. Accelerating charges in AC circuits containing inductors, capacitors can produce the radio waves. And the frequency of the radio waves is in this order, 5 into 10 power 9 hertz. Okay, and actually this consists of too many theory parts. Of course, theory questions are there. The basic things I am mentioning here, and rest you can even just refer any kind of book also for more and more information. Okay, I am not restricting the data with these points itself, it just like a commonly available things I am mentioning here. And these radio waves basically they are used in radio and TV communications. All right, this is about radio waves. And then wavelength segregation is already we have seen, and we will be having another slide, in that I will show it. Microwaves are produced by the oscillating current in electrical circuits. Okay, and they are used generally in radar systems, communication system, and microwave ovens. You know that how microwave ovens will work. Microwave oven will work based on these microwaves to cook the food. Okay, radar guns and all, we will use these microwaves which are having shorter wavelengths. Frequency range of this is 5 into 10 power 9 Hz to 10 power 12 Hz. Order is easy to remember, and if you go through that frequency chart once, that will help you to remember these frequency ranges. Okay. Infrared waves in generally, infrared rays are emitted from excitation of atoms and molecules. The excitation of atoms and molecules will produce the infrared rays. So we'll be having NERNEST lamp to produce IR rays. Okay, laser. This all which can produce IR rays. Frequency of this IR rays is 10 power 12 to 14 into 10 power 14. Actually, this order of magnitude is 10 power 12 to 10 power 14 Hz. They are used in physiotherapy to cure these muscular pains, muscular joint pains. IR waves are used. Okay. So I said already, incandescent lamps, NERNEST lamps, they will produce this IR lamp. They are the source of this IR rays. Visible rays, this is the what which we are we can say that visible light or visible light rays, with the help of which we are able to sense the objects, see the objects. Okay, so these things will be helpful in astronomy, photography, and for seeing the objects and all. Atoms under suitable conditions can emit these visible rays. Frequency of this is ranging from 10 power 14 Hz to 10 power 14 Hz. In that range, in the spectrum you have seen. Just a minute, I will show that previous slides once. Yeah, here it is, you can find. So this is the region where you can find out this visible region, visible light. Okay, so in the same frequency range, 10 power 14 Hz to 10 power 14 Hz, in the same range, they can find out these visible rays, where with the help of this you can find out you can see the objects. Okay, violet, indigo, blue, green, yellow, orange, and red VIBGYOR. Okay. Okay, fine. So here frequency range is this one, and how it will be we have seen just now. Ultraviolet rays, they are emitted from the sun rays. Even in fact about infrared rays, one point I remembered. That is what after incidenting on the surface, the IR rays will be reflected, right? That will be trapped by the greenhouse gases, and which causes the global warming. That's one of the major important point that we should understand. Okay, so I told you those so many theoretical points are there. Just you can find out by referring any other books also. UV rays here, why I recalled especially now, I just remember after seeing UV rays. Yeah, because ultraviolet rays also, and we are allowing them to fall on the skin. All right, we are allowing them to fall on the skin, and especially early in the mornings, to synthesize the D vitamin in the body, Okay, and these UV rays also will cause a very bad what I can say, if they penetrate through the body repeatedly, I mean overexposure may cause the tan effects, or it increases the content of melanin in the skin, so that tan will be increased. Okay, there are kind of drawbacks actually. Frequency of UV rays, they are ranging from 14 Hz to 10 power 17 Hz, 10 power 14 to 10 power 17 Hz. As I said, vitamin D is synthesized by the morning sun, hence these rays may be allowed to fall on our skin during that time to absorb the required vitamin D. Okay, X-rays here. So when the fast moving electrons are bombarded or striked, then X-rays will be produced. Okay, electrons are suddenly obstructed by a target, that's what, they are bombarded by the target, they are striked by the target, then X-rays will be produced. The frequency range of X-rays is from 10 power 16 Hz to 10 power 19 Hz, and some textbooks you can find this is from 10 power 17 Hz to 10 power 20 Hz. Earlier you have seen that 10 power 17 Hz to 10 power 20 Hz also. Okay, so that's what, there is no specific boundary for this. The range will be varying here and there. It's not even exact point. Okay, but just an approximated range, that's why. Okay, so you can follow this or this, it's up to you, choice, no issues. And then these rays used for medical purpose to identify the defect in the bone fractures and all. Okay, and overexposure of X-rays also will be causing in terms of, that radiation will affect the skin again, so it's harmful, it's not good. And the gamma rays, coming to the gamma rays, these gamma rays are developed in the nuclear fission and nuclear experiments. Okay, so in that nuclear decay, in that process we have learned like alpha decay, beta decay, gamma decay, alpha rays, beta rays, and gamma rays are developed in the enrichment process, or else what we can say, nuclear decay process. Okay, so these gamma rays are very powerful, they are having high penetrating power. When they are penetrated through the skin, they even can they can damage the tissues of the organs, tissues in the body. Okay, and we should be very careful with the gamma rays. Gamma rays they are shorter, wavelength is shorter than that X-rays. Gamma rays travel with the speed of light rays. Of course, in the free space, almost all these light rays, electromagnetic waves, can travel with the speed which is equals to the speed of the light. They have ability to pass through the human body and may destroy the cells, as I said, and will be used to treat in medical therapy also, like for cancer treatment especially. Gamma rays used in cancer therapy to kill the cancer cells. Okay. And so yeah, actually here I have taken this slide, details of wavelength range, production, detection of electromagnetic waves. It's because in the previous years one time you were asked about this particular case. Usually that write about these individual electromagnetic waves they may ask, or else this question was asked, a short answer question. Write about the details of wavelength range, production and detection of electromagnetic waves. That's why I have taken this onto the separate slide. Okay. See then, radio waves wavelength is given, that's range is from 0.1 meter, are produced by rapid acceleration, this we have seen. And the detected by the receiver's aerial with the help of the antenna. Mostly they will be used in TVs and FM, lower FM bands and AM bands, they will be used. Okay. Microwaves with a wavelength range of 0.1 to 1 millimeter and are produced by klystron or magnetron. And detecting objects is pointly contacted bodies can detect the microwaves. Infrared rays are infrared waves. Wavelength is 1 millimeter to 700 nanometer, and they can be detected by thermopiles, bolometer, or infrared photographic film. Okay. How they are produced, excitation of the atoms and molecules we have learned already. Visible light wavelength ranges from 700 nanometer to 400 nanometer, and this can also be detected with the help of photographic film. And then UV rays also can be detected with the help of photocells of photographic film, ranging the wavelength is from 400 nanometer to 1 nanometer. Whereas the X-rays is here, X-rays is ranging from 1 nanometer to 10 power minus 3 nanometer, and that these can be detected with the help of photographic film, Geiger tubes, ionization chamber. In fact, gamma rays also can be the same thing. Wavelength of this that will be varying from 10 power minus 40 nanometer to 10 power minus 10 nanometer, which is less than 10 power minus 3 nanometer actually. And the detection process is same how we are doing for X-rays. Okay. And you can see this chart where you can find out, this is a diagram that I have taken from the reference of NCERT. Wavelength range is given, production is given, detection is given. Radio waves to gamma rays in the order radio, microwave, infrared rays, and then light, which means visible rays, ultraviolet, X-rays and gamma rays. And the wavelength ranges are given greater than 0.1 meter. The same what we have discussed, it just tabulated like this. And these are the wavelength ranges for each and every electromagnetic wave that is listed out in the electromagnetic spectrum. And the production, just now we have seen how the production will be done and how they will be detected. All right. And yeah, that's all then. So this is a one-shot session on electromagnetic waves, and even the remaining chapters also will be done and will be uploaded in the practical 11 and 12 YouTube channel. If you have subscribed already, well and good. If not, please do subscribe and just connect to the practical 11 and 2 channels, YouTube channel for more updates. Thank you.
Bring learning alive practically.